In this video, we will go over trig functions and its inverses. So this is page 34 on your handout. Let's go over sine x graph. This is sine x. We have domain restriction on it. So both endpoints are from negative pi over 2 to pi over 2. Why we restrict the domain? Because we want its inverse as a function. Okay, so this is the graph of inverse function. So from this endpoint, I have x and y. We swap x and y, and this will be right here negative 1 and negative pi over 2. Okay, and the other end we have pi over 2 comma 1. Switch x and y coordinate, and this goes to 1 and pi over 2. And we flip this shape and we have graph like this. That is graph of inverse sine function. If you are not sure how to connect this, you can use a calculator to form a curve, okay? I usually draw at the bottom of the page, right corner, and then I flip the paper and I see the shape quickly. All right, so let's identify what's the minimum, what's the maximum, what's the domain, and what's the range. The domain range is swapped from the original function. And what is the interval of increase? Everywhere on the domain, right? Everywhere on the domain. So I will go with negative 1 to 1. You can use brackets or you can use parentheses. That's fine, okay? We usually use parentheses for interval of increase or decrease in higher level math class. What is the meaning of higher level math class? After pre-calculus, we learn calculus, right? So we will talk about range, the interval of increase, decrease, and we go with parentheses, not including endpoints. So that is fine. Next one, where the graph is decreasing? Nowhere. And x-intercept, y-intercept is given here. So that is at 0, 0. Sine 0 is 0, right? So it's the inverse function. Sine 0 is also 0. So we see that position. Now let's look at inverse of cosine. So to do that, let me see how cosine x look like. Okay, cosine x look like this, and we want to use only this shape. Okay, so it is from 0 to pi. This is 0 and 1, and this is pi and negative 1. We want to restrict the domain from 0 to pi to define its inverse as a function. So let's switch x and y coordinate and let's graph it. So this is from previous one like that, okay? This one was cosine function. We want to take only that part. So on the graph, I'd like to have this highlighted shape, okay? So let's graph it. So 0 and 1 goes to 1 and 0. Pi and negative 1 goes to negative 1 and pi. Okay. What's in the middle here? That is pi over 2 and 0, right? So 0 and pi over 2. And we have 3 points, just like the other graph. And then let's flip this graph, okay? This one, draw this shape on the right bottom corner and then flip this page. And what do we see? The shape of the graph, okay? So I need to connect the graph like this. So let's go like that. I tried to use green color, but it changed. All right, so let's answer the characteristics of this inverse of cosine function. You have a new paper. I delete that part from the old paper. What's the minimum value? 0, right? We are looking at this graph and you're reading y coordinates for the minimum. What is maximum value? Pi, that's right. Now we are talking about angles, right? Because it's an inverse function. What's the domain? Domain is negative 1 to 1, which was the range of the original function. What's the range? That's right. So this is 0 to pi. Describe intervals of increase. So from left to right, the graph is going down, down, down everywhere, right? So there is no increasing. Where do they decrease? Everywhere on the domain, right? What's the domain? Negative 1 to 1. So you can use brackets or parentheses. Either way, fine with me. Higher level, we use open parentheses for the interval of increase and decrease, ignoring the endpoints. What is x-intercept? X-intercept is that 1. That's right. Here, right? What's y-intercept? Pi over 2. That's right. Next one, we are going to look at the tangent function, and this is the inverse of tangent. So tangent function look like that with the vertical asymptotes, right? And we will flip this tangent function. This is tangent x. So instead of having vertical asymptote, we are going to have horizontal asymptotes, since we switch x and y values. And 0 and 0, you swap, it's same value, right? Okay, so I need to think about flipping this corner like that so we can see the graph of this shape, okay? So let's see. Can I just draw? Yeah, I can do that, but I noticed that I have pi over 4. Tangent pi over 4 is tangent 45 degrees 1. So vice versa, okay? So let's switch x coordinate, y coordinate. Inverse of tangent 1 is pi over 4, okay? So we have these points as reference points. So let's graph a shape like that. So this is the graph coming closer and closer to the horizontal asymptotes, right? Okay, so this is the graph of inverse of tangent. What is the maximum? There is no maximum. What is the minimum? There is no minimum, okay? It's keep going and going and going. So there is no maximum and no minimum. However, these numbers are bounded by this horizontal asymptote, okay? Even we don't have a point exactly on the graph, we can talk about the limit of that. That is called the bound. Right, what's the domain? All real numbers. What is the range? From negative pi over 2 to positive pi over 2. Do we include the endpoints? No, because we have horizontal asymptotes, okay? So open parentheses here, not the bracket. Number 5, describe the interval of increase. From left to right, the graph is increasing everywhere on the domain, right? What's the domain? All real numbers. Everywhere it's increasing. How about interval of decrease? None. That's right. And as x approaches infinity to the right, f of x going to higher, 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 right? But it's not going higher than this horizontal asymptote. So that is the bounded number. So what's the number? Pi over 2. This arrowheads doesn't mean equal to each other. It cannot be pi over 2. However, it's getting closer and closer to that number. That's called the limit. Okay? Idea of limit will be discussed in first chapter in calculus class. The other end, as x goes to negative infinity, where y goes? Y is approaching negative pi over 2. So those are called the bound, and that's related to and the behavior of the function. At the same time, it is horizontal asymptote. What's x-intercept? 0. What's y-intercept? 0. Any questions? Okay.